philosophies in the blockchain space right now. There's the modular blockchain design, monolithic blockchain design, and succinct blockchain design, which probably falls into the monolithic. So there's kind of these battles going on, and that's the state of the industry. And I think we all agree here that the modular design is the way to go. So that's kind of the way we see it, is we're focusing on the modular design, at least on this panel.
Hi there. My take is quite simple. I am from the ZK school, meaning we have to use ZK to do what we need to do. So we are constrained by all the mathematical constraints. So we have to play by the rules of physics. Essentially means the size of the proof and how much you can compute and how much overhead there is. So if there's a real breakthrough, we will have a real improvement. I don't foresee, I've been around for a while, 6 years in this BS of ZK. So I haven't seen, there have been lots of breakthroughs, but I haven't seen like breakthroughs that go, wow. So if something like that happens, yes, that'll be a huge change. Otherwise, same progress continues.
Hello. So whereas he's from ZK, I'm from an optimistic rollup. So I take the opposite side. I do think that we realize very well that what the scaling bottlenecks right now are, and that we should contribute back to layer ones to improve data availability. At the same time, like the pressure today is usability. So it's a matter of staying closer to what users want, what they try and are familiar with. So do you think platforms that serve EVM in like a vanilla way, that's the thing to have?
Yeah, we are really excited with the whole Ethereum roadmap, right? Providing support, explicit support for rollups. Because once you start to scale data availability, right, provide great data availability, and combine that with the execution scalability of rollups, right, of these different execution environments, you start to have the possibility of creating amazing apps that were not possible before, right? That either need CPU-intensive computations or that deal with a lot of data. So really excited about the future. Yeah.
Sounds good. Let's move on to our next question. What are some difficulties and obstacles roll-ups still have to overcome? I guess this time we'll go from the other end.
Sure, yeah. So I think a big obstacle is composability, and people have been discussing about that a lot. Not only composability inside a single rollup, but also communication between different rollups, and the ability to like aggregate out outputs maybe, right? And try not to fragment liquidity a lot, because you have these different silos of applications, and they all have like money inside, and then you lose liquidity around. You have a lot of friction moving around stuff. So I think that's a lot of research to be done there, and that's a big obstacle.
Right, so with composability, we got ever-increasing complexity, and to solve for complexity, you cannot really always commit to an easier design or simpler option, but you can try and go for encapsulation instead. And I think this is where the modular blockchain design trend is coming from, where everyone realizes that all these Lego blocks fit together, but then once you try and build a giant castle of these Lego blocks, you're trying kind of have a maintenance burden, and you want to limit how much of a burden that gets.
So I'm going to be the cynical guy in the crowd. I would say the market adoption thing normally gets really swept under the carpet. You can have the best tech, but generally speaking, because not all L2 pools are identical in that sense. The inter L2 is a very open problem. So there's this open market question. The biggest one wins in that sense.
Yeah, I would say just like the other guys, composability is pretty important. Standardizing on a ZK format, or so the ASIC market starts to form, and then just general adoption issues with UX, I think.
Yeah, so actually ZK in itself, it's super complicated, and just making it work like a full EVM, it's very complex. And then we have recently switched from a mindset of, is that even possible, to it's a matter of time, which is already a lot. But then again, I will also add that making it actually decentralized, it's a challenge, because even if the protocol allows for it, if you need crazy hardware requirements, it's again challenging as well to onboard operators for doing that. And then again, like if you have a lot of users, definitely there are gonna be fees, and it will be profitable, and this probably will happen. But yeah, it's kind of a network effect thing.
Yeah, so one of the major challenges we're still facing is the cost of call data as well, to add on to what's been said. And that's where things like EIP 4844, which we'll be talking about in a moment, come in, but also data availability platforms like Celestiums from Celestia come into that space. And those are just now starting to reach maturity, and we'll see what happens there. Additionally, general purpose EVM compatibility is still kind of open. Optimistic rollups have yet to provide fraud proofs, and ZK, with the ZK side, ZK rollups, there's still the situation of reverting transactions and accessing things like message.value. So these are all open questions that are still being solved right now, and they're definitely technical blockers.
Thanks for your input. Since we have an audience of developers here, right? What are some unique propositions of layer 2 rollups that may appeal to interested developers? Or how would you recommend to a developer on how to choose which chain, which layer 2 rollups?
From the side this time? What are you doing back and forth?
I guess I'll come back to the side then.
Sure, yeah. So layer 2s and rollups are a way to experiment with alternate execution layers and execution platforms without sacrificing the security that Ethereum provides. If that's something that's exciting to you, of course, like jump right in. Definitely look into ZK rollups, optimistic rollups, and all the solutions available. One thing to note is that if, there's a lot of diehard Solidity fans, and if you think that Solidity is the last word in smart contract development, I think we need to look at the general world of software engineering and see how things like Rust is currently upsetting C. There's a lot of disruption happening there, and there's a lot of improvement to be happening in that space. I myself work on the compiler for our language, so I see a lot of that space, and yeah, definitely pay attention to the trends and dive right in.
Yeah, so I would say that we are kind of in the opposite side. So we are actually going to opcode level compatibility with the EVM. And that basically means that developers will be able to use the tools that they are familiar with. So, Solidity compiler, Remix, like the RPC and so on. Which then again, definitely there are the space for alternative stuff. But on the other hand, by doing this, it's quite easy to migrate from layer 1 to layer 2. And yeah, we are also taking advantage of like the gas model and so on, that like beyond the programming language, it has a lot of security implications, and this has been battle tested.
Yeah, so I think the developers should start focusing on layer 2 UX, right? Usability, and in that model, you'd have to figure, like whoever's going to come up with the Web 2 usability, but in the Web 3 context, applied to layer 2s, is going to come up with some really cool stuff. That's going to be worth a lot. So I think having the paradigm of Web 3 and layer 2 with EVM compatibility, the builders can start building on the UXs now, knowing that ZK EVM and native ZK EVM is coming, and when that does happen, that all of their code will start plugging in. Like our partner project Mute, they started working on ZK, an AMM, but they built the UX ahead of time, knowing that even though ZK Sync isn't released yet, maybe in the future it will be, because it's going to be Web3 compliant. So all of their work will just work out of the box. So I would urge developers today just to start adding in the UX, thinking of layer 2s. So any layer 2 that's EVM compatible will just be, composable off the bat.
I'd probably say something slightly different. Like, know your use case and know what you can do and what you have access to. A lot of the things that everybody says you can do, you can't do. A lot of the stuff I'm not going to name names and go through stuff, but I can tell you, as somebody who's played around with most of the things out there in ZK space, what you hear is not what reality is. That you will only understand that when you actually start using it the first time. Okay? And that learning curve is an incredibly steep learning curve. So look at things which are easy. Somebody has done it. Lots of things are using it. Libraries are available. The curves are supported. The size of the proof of the right kind of shape. And what you want to do, this is the most important thing. What is it that you really want to do? That the characteristics really map up to whether it's ZK or optimistic or whatever it is. And that should be your deciding criteria. And then, do you really understand it? Do you have the resources? And the rest of it should guide you to where you need to go to.
Yeah, I think you make a good point there, where there are really different use cases for layer 2, and not all use cases need, for example, a specific cryptographic property, or maybe they need some specific cheaper transaction format, or they need more data. There are all kinds of different use cases, and I think there are like programs like Layer 2 Beats and other websites that try and make a good comparison of everything that's out there. Shout out to Layer 2 Beats, by the way. They really try compare security, compare the properties that all these platforms have. And over time, I hope that all these layer 2s improve. And I think that optimistic rollups, they will try and fit a use case that's more meant for like latency or like these faster computations. As in it's closer to what a machine bytecode looks like. Whereas ZK rollups, they may focus on faster liquidity event bridging.
Yeah, I also would like to echo this. I think it's very use case dependent. So like if you want to do a fast payment system, then probably ZK is for you. If you want to port an existing DeFi protocol that is running currently on Ethereum layer 1, then probably you should find an EVM equivalent layer 2. At Cartesi, we're trying to focus on CPU intensive computations. So all our technical decisions were focused on providing support to that, so we're optimistic. We have interactive fraud proofs. We actually have our own VM as well. So we wrote a deterministic RISC-V VM. So the idea is that you can actually, so the VM can boot Linux, so you can actually use mainstream software and all the libraries that you couldn't before, right? So if you're looking for flexibility, if you want to like do specific dApps that need those resources, then yeah, then Cartesi. But if you want to port something existing to the second layer, then maybe Optimism, maybe Arbitrum. If you want to do payment systems, then ZK. So it's very dependent on what you want to build. Yeah, there's a place for everyone.
Thanks for the input. And then the next question here is, so one of the more recent EIP that's being talked about quite often in the Ethereum community right now, it's EIP 4844 shard blob transactions. What are your thoughts on it?
So yeah, we're all super excited about the EIP, I guess, right? So it's a huge cost reduction for data. And it's exactly what rollups need, because rollups, they need data availability, but for not necessarily forever. They only need to ensure data availability under layer 1 consensus for a period of time. So people can sync up, and you can like generate your fraud proofs. And after that, okay, if you need to sync up a dApp that is 6 months old, then someone can provide you that data off-chain. You don't need it to be running on everyone's node all the time. I also love it that it's compatible with, forward compatible with dunk sharding. So I'm really excited about the future of Ethereum, and thank you for the efforts on that EIP. Yeah.
Yes, so I won't show my own EIP too hard. I'm co-authoring it. Of course, I'm looking forward to data availability and increases. Like what we're all here for is increases in capacity. We are all specializing in these different use cases, all these kind of like Cartesi or like the ZK rollups. We all have like our different use cases, and I do think that once there's enough capacity, they can all scale a lot further and all like basically grow this Ethereum ecosystem that we're building. And then if you really want to talk about the EIP technicalities, you can find me after this talk as well. And we'll do more presentations about that in the upcoming DevConnect.
It's incredibly hard to actually talk next after the guy who proposed an EIP. So I say, thank you for actually putting the proposal and walking it through. I mean, I don't think I have much to add. The guy says, creates the EIP next to you, tells you what it is. There you go.
For me, I think what the context is, it's breaking down data availability into a proof of replication, which is what like Celestia is doing, and the archiving, right? And in the context, what we're saying with EIP 4844 is that the proof of replication needs consensus. You need to know that the data's been reached consensus on the data, that it's in an opcode, that the hash exists, and maybe there's a proof on that. The archiving, we're saying, it doesn't need consensus. When you store the data, anyone can store the data, and you can pull it up for censorship resistance. It's breaking up the problem into two separate parts. An order one assumption, one of n, that anyone can store the data in the world. The same assumption as you syncing up to a Bitcoin node, assuming there's going to be at least one honest person there. And so only the replication is used with layer one security in mind, which is really important. It's the devil's in the details there. So you don't want to assume an honest minority assumption off a separate ledger, but you're putting this on layer one and doing the replication proof with the assumption that archiving could happen, anybody could store. So that's the main thing. So I'm super excited about it because I feel like I don't even think sharding's needed. I think this is going to give enough bandwidth for hundreds of thousands of account updates per second, and potentially way more transactions per second. So for me, this is holy grail stuff, and it's going to open the doors to many new use cases that we've never thought possible before. Probably within a year or so, I'd say.
Yeah, I fully resonate with what you said. I mean, certainly there are many storage solutions like decentralize it, but it's tricky to bring them to Ethereum in a trustless way. And so this construct is just fantastic. And furthermore, I would add that if this happens before, like if we don't have for the full Ethereum sharding, that would be great. Because, I mean, definitely rollups rely on cheap data availability to actually scale, or well, to make, I mean, it's like a storage, like more storage give you more throughput, cheaper storage give you like cheaper transactions on layer 2, and I mean, so yeah, you get the scaling there.
Sure. Yeah. To echo some of the sentiment that the others have said, it's obviously a great thing for rollups to have cheaper data availability. However, one thing that hasn't really been mentioned and hasn't really been talked about is that this does increase block size, and when you have an increase in block size, you also have an increase in centralization, i.e. a decrease in decentralization. This might not be a particularly egregious infraction there. However, we really need to decide where our priorities lie with trading off centralization, decentralization for transaction fees. So, yeah, I think it's an open question there. EIP 4844 is great for rollups, but we should start kind of asking these hard questions before it gets too late.
Well, that's about all the questions I have.
With time to spare.
Yep. Anyone got any question for the panelists? Oh, we got one over there. Let me run down.
First of all, thank you. My question is on offboarding from layer 2s. What are your thoughts on offboarding from layer 2 to the real world? And like, what solutions have you seen for that?
Is this a question specifically about bridging, or more so about liquidity providers to provide this fiat gateway?
Yeah, more on the second one. So how do you convert from layer 2 to fiat, basically? Yeah.
It's a difficult application layer question for the protocol devs. Great. So I do think that essentially all these layer 2s we're building with Ethereum in some capacity because we're trying to work with a more secure bridge to mainnet where all this liquidity lives. And as use cases grow, I think these gateways will generalize and like provide this gateway to every layer 2.
I think Anisha, anyone have anything to add?
Any more comments?
Well, I know like Bybit is opening up a fiat gateway with ZK Sync, and a lot of the exchanges are, there's a lot of money they can make. So found the exchanges are just plugging them in, and as they come, they'll plug them in because there's so much incentive. There's going to be like a big, when ZK Sync comes out, it's going to be huge, and then they're going to plug in, Optimism and Arbiter plug in. They're already on exchanges, so I feel like the exchanges are, it's easy for them to see value and start plugging in these as deposits and withdrawals.
Yeah, and anyway, if you can make like fiat go to layer 1, Actually, rollups can achieve very nice bridges in the sense of that they can be fully smart contract based. So if you get your funds on layer 1, it should be quite secure to go to layer 2, and it shouldn't be quite complicated.
We have 1 minute left. Should we take one more question, or anyone got anything more to add?
Come see my talk later today.
What time? What time?
That's a good question. I think it is at 3:30 to 3:55.
Okay, I guess we can wrap up our panel here then. Thanks everyone for attending. And thanks to all the panelists, of course.